So good thing to do is just go ahead and try to do an example. So I will straight up say is that I do not use Spark on my PySpark on my local computer. It just isn't something I usually come across. Usually Pandas does a perfectly great job, so I won't use it that way. Usually if I use it, it would basically be like, classically I've done it mostly with Google Cloud Platform, but I've done it with some AWS. And so that's kind of like a whole nother thing of setup and everything going through. But you know, I think as a practice for you guys, practicing PySpark will be awesome. To be quite honest, you probably don't have to use PySpark if you're doing like your capstone or any project coming up. You guys are on module 5, is that right? Yeah. So you guys will have your, what's it, your machine learning project coming up. You guys haven't been interested in that yet, right? It's coming up maybe like next week.
It starts like now.
Oh, it starts now? Perfect. Okay. So in reality, you probably don't have to use PySpark. So if you're kind of worried like, oh, like I've done this whole other like way of doing things, you probably don't have to use it. You know, it might be good practice if you're feeling up for it. It might be good, but I think for the most part, don't worry too much about it. But again, good practice. But I'm going to show you something. So one thing I have is, it looks like MrJob, but it's just MRJob, so MapReduce job. If you install this guy right here, basically it allows a package to run MapReduce jobs with Python. So I don't have to use any special Spark. And this helps us, makes it a little bit easier for us to understand what's going on. Like, hey, like how is this even working? And basically this right here, this is like as if I typed in the terminal. So you could literally type, if you're in the right place, Python songcount.py, which is basically our programming file, right? So r.py, so it's not a notebook. Basically, it's a bunch of Python code. And then I'm passing in the actual data songs. So to show you what that looks like, let me go ahead and close these guys since we don't need them. And you can see here is I have, for example, our song count py, and we're gonna first look at this data set of song plays. So you can see here is that this data set basically just has a list of songs that were played. So basically you can think of this data set as like, and this is something I actually got from GitHub. It's not something I got specifically made myself, but so it's fake data, just so you know. But basically these are different song titles, and basically maybe it's someone's like playlist going through, and how many times they want to say how many times they learn to dig dreams, how many times they listen to Data House Rock, and Broken Networks and stuff like that. So it's kind of broken up in this way. And so I want to say how many times do they do this? How many times do they play each song? So I created a Python file, and you can see just .py. So you can see here is that you can edit these directly within Jupyter Notebook. If you get really fancy, you can use an IDE. So you can see here just song counts. I can just click this and it'll open up. Okay. And so basically I'm using this specific package so I don't have to use like Spark or anything too fancy. Basically I'm just gonna make, okay, like MapReduce job. And you basically create a class, and this is true for Spark as well. I'm taking this class, I'm creating this MR count song. So that's my own personal class that I've made, right? I'm inheriting the properties of MRJob. So that way I don't have to, you know, recreate this stuff and stuff. There's some extra background stuff in MRJob, like class, where I don't have to worry about it. So I'm like, okay, cool. And all I have to do is define a mapper and a reducer, and that's kind of it. So you can see here, basically, is that my mapper, you can see it's relatively simple. And so you can see that I'm passing in self, like we always do with classes, right? And we pass in this underscore, and this is song. Does anyone remember what the underscore represents when we have it pass into like a function like this, or for a for loop? Yeah, so that's all right. And so kind of going back, if I went to like, I like to show this part. So if I do like for I in, I'm gonna make a random list of like 1, 2, 2, 3. Okay, so I can normally do this, right? And then just print I, right? And you can see it basically grabs this whole guy right here. I could also do, if I'm really fancy, I can print IJ, right? And if I just print, basically this would take 1, 2, going from there. And so this would just print out 1 and 2. Okay, if I wanted just the J part. Okay, I could also do like, for example, J plus I or something like that. And you would basically do 1 plus 2 and then 2 plus 3. Okay, you guys have seen this before, something like this. Cool. So one thing I do is, well, let's say I'm only gonna print out J, and I don't really care about I can just use an underscore to say, I don't care about this variable. Basically, it's my placeholder. And so I can just print out J and not worry about this I right here, or whatever this would represent, basically the first letter right here, or first number going through. So that's kind of like how you can kind of do some things in Python. So oh, just ignore this. It doesn't matter. That's what's going on in the songs pie right here. Is this underscore is saying, hey, like, don't worry about it, because what happens is that this MRJob is going to pass on each line. It's going to look at each line, which remember our line looks like this. Okay, and it's going to say each line, and it says, all right, what is the key and what is basically the other value? So it's key, comma, value. And basically it's like, well, there's not really like a key here. It's just the name of the song. So I'm just gonna say, okay, ignore that part, right? And just get the song, basically the name. And so what this will happen, this yield, and have you guys seen yield before? This is kind of, all right. So one way you can kind of think about this is a return function. You can kind of replace return and yield with each other. Yield really represents something called a generator. And this is where it's like, what's a generator? You guys have been using generators, you just haven't known it. One thing, for example, if I wanted to do, let's say I can do like, I can 0, 1, 2, 3, oops. Here, okay. I could do this, right? And you're like, okay, that's cool, but you know better because you guys are fancy Python people. You can just do range, right? Of 3. That's going to be one less, but you get the point. So you can say, oh, range of like 4, so 4 different elements, right? And you're like, oh, cool. Like we've taught you about this pretty early on, right? Has anyone ever tried printing out just range? You guys know what it prints out? Yeah, I don't know, right? It's doing something, because remember, we could replace that with a list, right? So most people would say, oh, it probably does like a list of like 0, 1, 2, 3, 4, right? That's what we had before, since it's the same thing. Actually, in Python 2, that was true. In Python 3, you'll notice that it gives this weird object. You're like, oh, what is this? And you can actually check out this type. And you can see, oh, it's a type range. Oh, that's super helpful, Python. But yeah, it's a different thing from a list. So you can see here, basically, it's trying to represent a 0 to 4. So one thing we can do is actually do list of this, and that converts into our nice, beautiful list, right? What this range is actually, and this is where we can get, oops, lost it for a second. If I do Shift Tab, we can see like what this is going on here, and you'll see here is that basically it's a generator. So it's return an object, reproduces a sequence of strings. And this is basically doing an increment. So what's really happening, it's kind of cool, is that what this range 4 does, it's not having a list and it's getting the first element. Basically, every time it goes in this loop, it goes 4j, give me the first one. It tells it its range 4. And it goes, okay, the first one is 0. And then it does its things and it goes back up. And then it says, give me the second one. It goes, okay, the second one, here it is. It doesn't actually have to store that information. It actually is keeping that information as it gets passed through. It basically generates or yields a new number every time you ask for it. That's what this yield here is basically saying. It's giving something out every time you ask for it. So it might read in the whole like line right there, but it's only going to yield this one part each individual time. This is a little more memory efficient. Generators, again, are kind of this funky thing in Python. There's a whole thing we could talk about generators. But the important part to know is that it doesn't have to store it all in memory at once. It just does it as you ask it. So it's a nice way to basically make it more efficient. So basically what's going to happen here, it's the name of the song, and says, all right, it happened one time. So we can imagine like our little thing from the curriculum. Basically, it's just mapping each part. Or it does a split. The split's kind of done in the background, so we don't have to worry about it. And then the mapper basically is doing that split. It says, all right, take each of those parts, that line, and say, all right, song 1, that's what it is, okay? And then after that, we move on to our shuffle part, which it obviously does this in the background since we didn't define it. Okay, so it basically figures out what things belong to where, splits up, it's a resource manager, so we don't have to worry about it ourselves. And then it says, okay, let's reduce it. And this is when it reduces like that set of, basically song, comma, 1. And what will happen here, it's just going to sum up all these values. So we have passed in our key. In this case, the key is actually the same name as the song, okay? And we're going to sum up the values of that tuple to get the total number of plays. So we can actually add up all of those numbers and then yield that key, comma, sum, which is going to be how many songs were played with that pass through. And that's our reduce step. And so this guy right here, you guys have not seen this before, right? So this is some object-oriented stuff. So what this has done before, you guys have seen this underscore to begin with, right? Just like you might have seen, like, for example, underscore init. You guys have seen that before, right? So this underscore name actually exists as a hidden variable within Python. Whenever you see those underscores, you actually have it's actually a variable in here. So if I actually do like type, this just, I think it comes out of the string, could be wrong. Yeah, so basically it's a hidden variable that's built into here. And so what happens here is basically saying, if I run this, if it's the main function, go ahead and run my count songs, run the method run. And this run will implicitly call the split, the mapper, the shuffle, and the reducer. Basically, it'll do that all for us, and then it'll print out our nice, beautiful thing. But the important part is understanding how to write this part. This is usually the tough thing to do. So, and note that this is not the same thing as the curriculum, but I'm showing you another common way that people will do a MapReduce. And I think this shows the same concept, is that we're taking the song name, passing number 1, and then taking each of those song names after they've been split and shuffled, or sorry, mapped and shuffled. You then add up all the sums, just like we had in that little diagram. So the question now is, how do we run this, right? So all we got to do now, you could do this directly in the terminal. Here it is. But basically our Python song count, which was the name of this guy, we're passing in the data right here. So note that's in the data format. And we should be able to get the number of songs coming through. And you can see here, it outputs here. You can see some extra information that's coming from the MRJob class. Okay, and it's running through. Basically, it's figuring out what to do. And then outputs, Deep Dreams, 1,131 times, Data House Rock, 828, Broken Networks, 510. So there were only 3 different songs. And then basically say, okay, cool. And you'll notice here that actually has some extra information to put in the folders. But the point is that we can actually do this stuff. Okay. How's that all sound to everyone? Thumbs up if you're like, I got that. Someone's like, I don't know. Thumbs down like, I don't know what you're talking about.
I mean, I understand what you're doing, but like we actually didn't learn to do it this way. It's just interesting to see your method of doing it, I would say. I like how you're running from a Py file and then like.
Yeah, and this is more realistic of what you will see in like the job world, is that they'll have a Python file directly, not a Jupyter notebook, because it makes more sense for them to be able to pass around just basically the Python itself. Jupyter notebooks are kind of like, it's like Markdown mixed with Python, and it makes sense for them to, let me just get the Python file. You also know you can always go file download as python.py, so you can actually get just the Python file. Do you guys know about that? That's fun. Let's see if I can, You didn't? That's okay. Yeah, so you can actually take that, and I'll just quickly show you. You guys want to see what it looks like? You guys can do it on your own, right? You guys don't want me to fuck you through that. But you can download the Python file itself. So you can write in Jupyter Notebook because that's what you're comfortable with, and then just download the Python file and then pass it along to whoever you need it to. Okay, cool. So who has done the, oh good, I have about 5 minutes, so be enough time maybe to get through it. Who has done the lab with the word counts on section 40? Have everyone done that? So I see Matthew say it, Dennis, Savannah, it's cool. All right, cool. So I'll show you how you can do this with just this MapReducer, right? Or with this MRJob. So I actually have this written out. I don't know if I finished doing this. Oh, we'll see. Okay, I don't think I tested it out yet, but basically the same idea here. We have a mapper, we have a reducer. You notice the reducer is super simple, right? And we have our mapper here. I really should just put parentheses around this part. Okay. And so we have our mapper that's also reading in our line per line. And remember what, let's see here, Romeo and Juliet looks like. You can see basically each line is a bunch of words. So all we gotta do is take each line and just count up how often they come up, right? So I actually don't know if, is that right? In the lab, you're counting how many times words occur. Is that right? Yeah, so this should do the same thing. So what we're doing here basically is we're making sure like we exclude some stuff. For example, making sure like we don't include punctuations. They're not words. We're stripping things out. So we're stripping out basically each, you guys know what line.strip does. So it splits up all those words, right, by spaces and extra space, stuff like that. And then we'll actually take out that line, we'll do the strip, we translate, make sure to get rid of all of the punctuation because we don't care about any punctuation. And then we'll actually do the actual split, and the split will make it into a list of words. And then for each word, it's going to yield a new word. So this is kind of, again, where yield makes a lot more different, or probably makes a lot more different from like what your return, because basically what will happen is it will do a yield, but then if you put a return here, it would stop the function after the first one. But what happens with like a generator, basically you can keep asking for it, give me the next one, and it'll continue that for loop and say, all right, give me the next one, give me the next one, give me the next one. So we can actually yield out each word for that specific line. Okay, and so again, the word is just the key itself. One is the number itself, or the value, right? And then we pass it on, does a shuffle thing, and then gets over to the reducer, and the reducer is just gonna say, all right, take each word and pass out the sum and counts. And I'll put this in parentheses to make it within me. Everyone, does that make sense to everyone? This is probably the most confusing part right here. Yeah.
Yield into a list.
I'm sorry?
Does it make it into a list?
It doesn't make it into a list. It's more like it's more like a return. So like if you imagine I put return here, it's just returning the tuple of the first word in words and then passing it through. So it's kind of like when you say like returns a list, do you mean like how I showed like range and then the list around it?
Well, maybe I was misunderstanding how yield works. I was thinking it was gonna send it as a list of every word in words, but now you're saying it's just the first one?
Yeah, so this is a generator, so it's kind of strange. It's kind of working in the background, so that's why you don't usually notice this. But like when you ask for range, it's not that it generates a list of range from like, let's say range 100, it goes from 0 to 100. It doesn't actually make a list of 0 to 100. It basically just is starting off with the first one, says, all right, I have the first value. And it's just like waiting around for Python to say, hey, give me the first value. Like, oh, here it is, gives you the first value. And then it waits for Python to ask again. It's like, oh, let me get the second value for you, and creates the second value and goes through. So what's happening here, if you were to like call the mapper and say, give me the next one, give me the next one, give me the next one, it basically would continue this for loop. So basically it's kind of like pauses the for loop and it just waits with its little thumbs twiddling, you know, says, all right, I'll wait until someone asks me for the next value. It says, oh, you want the next value? Okay, cool. Let me get the next word, goes through here, and then return that word. Hopefully that kind of makes a little more sense.
Yeah, I guess maybe I'm curious how it gets called on the other side, that how it can like take...
Definitely. And this is where I would recommend.
I don't want to derail the lesson though. It's just, it's something I could look up, I guess.
No, it's a good question because generators are not simple. I would strongly suggest like go look up generators in Python and see what those work. They're not super intuitive. I think our brains don't naturally think in that way. But once you go through it, you're like, oh, okay, it's just asking for that next part. There's a way you can explicitly call this, but just know that that's why we're returning a generator itself. So it can basically just keep asking for the next one. Okay, cool. But I'll show you how this works since I realize I'm kind of low on time. So I have this part loaded in, I'm passing that text, and hopefully we'll actually get, I haven't tested this out yet, so we'll go through, an error. What I messed up? Oh, I messed something up. But in principle, this will work. And this is where the programming steps would be useful if you're going through everything. But the idea here, it should still be the same, is that we're basically getting a single line. And then from that one line, splitting those up into words and just generating out each individual word and then actually yielding each part. Okay, cool. Yeah, so I guess that's kind of all I had planned for you. I'm kind of low on time, but any other questions you guys might have? Other than that generator part's good question. I'll send out a resource on your guys' Slack to see, maybe it explains a little bit more about what generators are doing. Okay, cool. And I like to show these things too, because I feel like it's important for you to realize that there's not gonna be like this one way and then someone says, oh, have you done it this way? And they're like, that way exists. There's a lot of different ways people approach these things, but the concept of MapReduce is the important concept. It's not how to do it in PySpark necessarily. It's like, what is MapReduce doing? And then being able to apply it to whatever tool is given to you in, you know, wherever you work or whatever your career is asking for. All right, cool. So I'll go ahead and stop recording here then. You guys will. All right.